Alright guys, here is the first day of calculus with the flipped classroom. Today what we're going to talk about is extrema on an interval. What extrema are the highs and the lows of your curves. So this is chapter 3 and we're going to apply all of the stuff that we learned in chapter 2. So the first part of chapter 3 deals with the extreme values, which is a minimum or a maximum, a relative maximum, and a relative minimum. So, let's do some vocab. A minimum is on a closed interval. For example, if they tell you or ask you to look at -5 to 5 on your interval, those are x values. So if we look at our graph between those values, so that's the window we're going to look at, we're going to label our minimum as the value that is in our valley. So that bottom value. For a maximum, it's also on a closed interval. So example, from -5 to 5, we're going to look at the window and we're going to be looking for a high spot. So a relative maximum is when you have no interval. So it's going from -infinity to infinity. So you can look at your whole graph and you can figure out where the highs and the lows are. A relative minimum is also with no bounds, and so we label it that way. Critical numbers are numbers where your derivative is set equal to 0. So if it's our derivative, what does our derivative represent? That is slope. So if our derivative is slope, and our slope is 0, what kind of line, kind of tangent line would have a slope of 0? Well, what kind of lines have 0 for a slope? And that is a horizontal tangent. So critical numbers are values where you have a horizontal tangent. And that means your derivative is 0 because your slope is 0. So on your test in chapter 2, I asked you, tell me where, what values of x make the derivative, or values for your function have 0 as their slope for a tangent line. And that's what you should have done. So, critical numbers can also exist when there is a hole or an asymptote. So holes are when our graph is continuing forever but then has an open circle. And asymptotes are those lovely dotted lines that our graph will never touch but come close to. So, if we have this equation here, x cubed times the quantity 2x minus 1, and we want to figure out where the critical numbers are, first we have to find the derivative. So, derivative is x cubed and 2x minus 1. Make us do product rule. So we have our first times the derivative of our, and then our second. So I would go ahead and do, you guys on your own can do the derivative, pause it, and then come back. So 3x squared and 2. Crisscross, 2x cubed. Crisscross, I'm going to go ahead and multiply as I crisscross, so I get 6x cubed minus 3x squared. This is my derivative. I'm going to go ahead and simplify that one more time, and I get 8x cubed minus 3x squared. So if this is our derivative, and we want to know where the critical numbers are, we're going to set that equal to 0. And we are going to find out what x value makes that 0. So here's where factoring comes into play. Since you have two terms that both have x squared in common, I'm going to pull out an x squared. And so we get 8x minus 3. And from there, I'm going to set each part equal to 0. So 0 equals x squared. So that gives me at 0, we have a horizontal tangent. So we either have a high point at x equals 0 or a low point. Here we got 8x minus 3 equals 0. So x equals 3/8. And I would get that by solving for x. Add 3 divided by 8. So when x is 0 and x is 3/8, you have either a high or a low in your graph. So what I would do from there is I want to find the y value. So to find the y value, if you plug into the derivative, you plug x into the derivative, you're going to get 0 because the derivative gives you slope. We want our y value, so we're going to plug into the original. So if I plug in, so original is where we're going to plug. If I plug in 0, I get 0 times anything is 0, so I get 0. So my ordered pair is 0, 0. That is a critical number. Here, if we plug in 3/8, so we got y equals 3/8 cubed times 2 times 3/8 minus 1. And that will be negative 27 over 2048. So our x value was 3/8, and our y value was that crazy fraction there. So I'll let you look at that. I want to make sure that it's getting all of our information in there. All right. So on this one, we're going to find the critical numbers. By the way, on those, since it was not a closed interval, it didn't tell you what values to look at, it would have been a relative maximum or a relative minimum. All right. Oh man, I'm frozen.